As I look at 71, I see that it's a piecewise function, and I see that there are 3 pieces. I see that the first one is negative 1/2 x minus 4, and that's just when x is less than negative 2. So I'm going to make a little t-chart to support me in drawing that function with x values of negative 2 and a number that's also smaller than negative 2, so negative 4. At negative 2, I'm going to put the open circle. So I'm just reminded that these functions here, here's negative 2 for x. I'm going to have an open circle, whoops, going that way. Then I'm going to have a segment. This one has a closed circle. It's going to go all the way to 5. And then I'm going to have a closed circle at 5 and going forward. So these are what the end pieces of my piecewise functions will look like. So my first piece that I'm working on now is going to have an open circle and an arrow pointing towards the left. So with the x value of negative 2, that's going to be negative 1/2 times negative 2. So positive 1 minus 4, so negative 3. For negative 4, that's negative 1/2 of negative 4. That's the negative times the negative, so positive, and 1/2 of 4 is 2. 2 minus 4 is negative 2. So I'm going to plot these ordered pairs. Negative 2 for x, negative 3 for y with the open circle. Negative 4 for x and negative 2 for y. And then I can continue this pattern up and backwards, up and backwards, up and backwards. That slope of negative 1/2. Once I see that slope, I just need those 2 ordered pairs to get me started. So remember, this piece is only on this part of the graph that matches that ray above it. The middle piece is the constant function 5, which is awesome. That's the y value of 5. So I'm just going to draw this segment starting at negative 2 with the closed circle, and then going until 5 at the closed with the open circle, and those are at the y value of 5, meaning it's a horizontal segment. Now I'm working on my third piece. That's x, when x is greater than or equal to 5. So that just means I plug in 4x, 5, and then another number that's bigger than 5, such as 6. The x values repeat for the function x. So it's 5, 5, and then 6, 6. That's the slope of 1. So I start here at the open circle. I go up 1 over 1. And I connect my piece. I'm now finished with this piecewise graph. So I totally forgot about these piecewise functions. It's been so long since I've graphed one. We make the t-tables, we use those open and closed circles, and those are determined by these rays here. So this one says x is less than 0. So that first piece is going to start at 0 for x, and less than goes this direction, and it's an open circle. For 3x plus 5, I could graph that, right? The m is equal to 3, the b is equal to 5. But I like to just plug in these ordered pairs. So I'm going to plug in 0, that's the open circle, and I'll plug in negative 1. When I plug in 0, I get 5. When I plug in negative 1, I get 2. That's going to really help me draw this shape. So 0 for x, 5 for y, open circle there.
Please pardon the interruption. Students, please pick up your yearbooks in room B20 starting at lunch today. Yearbooks will be distributed in B20. Thank you very much.
Cool. So here I see that slope of up 1 over 3, but I'm going down 1 and backwards 3. So I'll go down 3 and back. I'm sorry, down 3 and backwards 1, going this way, down 3, backwards 1, down 3, backwards 1, when we're going the wrong way. Okay, cool. So then the next part is x plus 5. And I've got a closed circle at 0 and then an open circle at 3. And that's a segment. So I'm going to plug in 0 and 3 for x. I always plug in the exact values that they tell me to plug in to x plus 5. So 0 plus 5 is 5. And then 3 plus 5 is 8. So at 0, 5, I'm going to put the closed circle. Okay. And then 3 for x and 8 for y. I'm going to put my open circle, which I didn't do. I'm going to put my open circle. Then I connect those two pieces. Finally, for the x is greater than or equal to 3, that's a closed circle at 3 and going this way. That one is the constant function 8, which is a horizontal line at the y value of 8, which I'm actually already at. So filling that in. Looks great. Huh, cool. So I draw those little support segment pieces up at the top. It helps me because then I have that visual, what is it going to look like in those spaces, and I remember where I'll be changing equations. I make my t-tables just to make sure that I'm doing it right, because with slope, I want to make sure that I'm counting it correctly, and I'll get messed up going the wrong way sometimes. All right, cool. 73 and 74, these are totally crazy problems. This is first semester, and these are polynomials. So we're seeing that end behavior down here. So looking at 73, I wonder if my graphs will show up or not. Oh man, there they are. Okay, cool. All right, so I love this. We did a warm up of this a few weeks ago. And so we're gonna find the x-intercepts, which is just setting each of those equal to 0. So we've got x, that'd be 0. X minus 4 would be 4. X plus 3 would be -3. And x minus 9 would be 9. Love it. So now we want to put those dots along the x-axis. 0, 4, 9, and -3. What I'm missing here is the degree. Let's write that in. The degree is something that's really helpful in determining which shape this is going to be. Counting up the x's, there's 1, 2, 3, 4. This is a 4th degree. So just like a parabola, this is going to have the arrows pointing in the same direction. I noticed that the a value is negative. So that means that both of the arrows are going to point down. So as x is going towards -infinity, y goes towards -infinity for both sides, is what that means. And I determine that based on the degree and the a value. With odd degree, the arrows point in different directions or opposite. So now I just want to connect these. It's going to make a W shape. 1, 2, 3, 4. Jackson. So 74, I can tell it's going to be kind of the same, but different. Oh, I forgot my y-intercept. Do you guys know the y-intercept already? I hope you do. Yeah, 0, 0. We already passed through right at the origin. Okay, so 74, we see that it's not in factored form. We see that it's a polynomial with 4 terms. So I'm going to zoom in on that mentally and actually, and I'm going to count 1, 2, and then up, and 3, 4. I see that it's x to the 3rd plus 5x squared. So I can take out an x squared from both of those. And that's going to give me x squared and then x plus 5 left behind. Now the GCF of the last 2 terms is going to be -1. And that's going to give me x plus 5 again. So my binomials match. That's awesome. I'm going to write this as x squared minus 1 times x plus 5. Uh-oh, x squared minus 1 is a special pattern. So this needs to be factored further. As a reminder, I'm going to draw out my t-table. This is x squared plus 0x minus 1 if I write it as a trinomial. And so I want the numbers to multiply to -1 and then add to 0. And as I'm thinking of that, I want 1 times -1 because 1 minus 1 is 0. So this will factor to x plus 1, x minus 1, and still x plus 5 as the final factored form. So that x squared minus 1, that was a special pattern called the difference of 2 squared. One was positive and one is negative. And so that's going to tell me my x-intercepts. I'm going to have -1, +1. Oops. I must have zoomed out too far. And then is it 5 or -5? I can't remember. And -5. So -1, 1, and -5. This is degree of 3. Degree of 3 means that we've got opposite end behavior like a line. Since the a value is positive, we'll end up in the positive quadrants. So I'm going to put my arrows there right away. The y-intercept is what you get by plugging in 0 for x. And it's actually easiest to do that in the original equation. Coming back to this original equation, if I erase the work that I did so I could see it a little bit better, it's 0 plus 0 minus 0 minus 5, right? I plug in 0 for x and all these turn to 0. So my answer for the y-intercept is 0, -5. So plotting my -1, my +1, and my -5, I can see how this picture is going to look. I'm now going to try to connect my dots close to my arrows. All right, I didn't quite make it there. And now I want to remind myself how this end behavior works. So here's -infinity for x. We see that the y value here is pointing down towards -infinity. And then here's +infinity for x. And where's the y value pointing over here? Here it is. It's pointing up towards +infinity. So when we say opposite end behavior, we're talking about the y values going, one is going to +infinity, the other is going towards -infinity. Those are polynomials. Okay, I'm hoping that 75 and 76 are not on yours, are they? These have been cut off, these are not your current, these are not. They are there? Okay, well, we're just gonna go like this. We didn't go over that. That was easy. We didn't do systems this year. All right, for 77, 78, 79, and 80, we're looking to write an equation. 77 looks a lot like the problem that we just did. It's a W shape, but it's pointing up. So let's take a moment and identify the x-intercepts to create an equation. We're at -5, we're at 0, and we're at 4. However, that's only 3 x-intercepts, and we can tell based on the end behavior that this is a degree of 4 because both arrows are pointing in the same direction. So is there a bounce going on here? Yes, there is. There's a bounce happening right here at the origin. And that comes from a multiplicity of 2, which just means that there's an exponent of 2 on that x-intercept. So I'm going to write y equals And I'm going to write these as x for the 0 squared. Then I'm going to have x plus 5, and that's the x minus 5, right? And then over here, the 4, x minus 4. And this is that pattern, x minus r1, x minus r2, x minus ... That same pattern for however many roots there are, or x-intercepts. Cool. Looking at number 78, I noticed that one is an absolute value graph. I can tell based on the shape being a V. So the absolute value is the m, or the slope, and then the x minus h plus k, where h and k are the vertex. I was easily able to identify the vertex as -1, -3. Someone's already out in the bathroom, so you'll need to wait. Thank you. So because of that, we're going to be able to now count for the slope. The arrows are pointing up. And I count up 1 and over 1, so the m is equal to just 1. Since the slope is 1, I'm going to write the equation as y equals absolute value of x plus 1 minus 3. Sweet. At 79 and 80, I'm seeing some second semester functions. 79, I'm seeing the 1 over x function. And so that's going to be a, and then it's x minus h plus k. The hk is the intersection of the asymptotes. So I'm going to see that that is at 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 6, 4. So that's going to be my h and my k. The thing that's going to be a little bit hard for me to determine is the a value. So a value of 1 would be right here. Definitely not an a value of 1. So based on this, I see that the a value is negative. So we're going to use an ordered pair to determine this. This is the algebraic method. So I see this really bold ordered pair at at 5, and then 4, 5, 6. So we see that ordered pair at 5, 6. I'm going to say a, x minus 6, and then plus 4 is equal to y. So we've plugged in our hk, and we have one other ordered pair. The ordered pair goes like this, x, y. So I'm going to replace the y value with the number 6 and the x value with the number 5. Let's do it. So the y is 6, a, then x is going to be 5, 5 minus 6, plus 4. I will now be able to solve for a. 5 minus 6 is -1. So I've got a divided by -1 plus 4 is equal to 6. Subtract 4. It's going to give me 2 is equal to a divided by -1. So timesing by -1. I've got a is equal to -2. And so I'm just going to erase my a and replace it with the number -2. And I feel amazing. I have my full answer. Cool. Looking at 80, it looks like half of a parabola, meaning that that is my square root function. Got our a, x minus h plus k. So I'm easily able to identify the hk as that starting point right here. -1, 2, 3, 4, oh, -5. And then up here is going to be down 2 from the top, so that's 8. -5, 8. Now this a value, I can actually tell by looking at it. With an a value of 1, we go up 1 and over 1. But here we've gone down 2 and over 1. So what does that mean our a value is? Negative what? -2. So I'm going to have -2, x plus 5 plus 8 as my final answer. Hunter, I'd appreciate if you put your phone away. Thank you. Now for 81 through 104, it's just determine the type of equation and solve. That means that we want to find the answer for x. Looking at these, we've got a wide variety of problems starting off. So if I'm determining the type of equation for number 1, I see no interesting operations or exponents. This is a linear equation. What that means is I'm only going to get one answer for x. This one should be pretty straightforward. We're going to distribute -2 and simplify our like terms and figure out x. It's 10 minus 12x plus 10 is equal to 2x plus 5. Combining my 10 and 10 on the left-hand side, I have -12x plus 20 is equal to 2x plus 5. Oh, I had an x. Thank you. I didn't even see that. That's going to change my answer. I'm going to combine these two to get -2x plus 10. So 2x and 2x would be a concern, but here it's -2x and +2x, so I'm not concerned. I'm going to combine my x's across the equal sign with opposites. So I add 2x here and I add 2x here. That's going to be 10 is equal to 4x plus 5. I'm going to subtract 5 and then divide by 4. So I've got x is equal to the fraction 5/4. And I always leave my answer in the form that I found it in. All right, cool. 81 is done. Let's move on to 82. Hopefully you can easily see that 82 is absolute value. So this one we're expecting to get 2 answers from. Because remember, absolute value could have 2 possible places where it intersects with the x-axis. So I want to isolate the absolute value symbol first. And in order to do that, I'm going to subtract 3. And I have the negative absolute value of 2y plus 4 is equal to, well, these are both negative, so I add -20. Now we never distribute a negative into an absolute value. That's unheard of. We divide both sides by -1. Now I have 2y plus 4 is equal to 20. Sorry, the 2y plus 4 is an absolute value. It's at this step that we generate 2 different equations because there are 2 numbers that have an absolute value of 20 or 20 units away from 0. That's 2y plus 4 is equal to +20 as shown, or possibly 2y plus 4 is equal to -20. But when we have -20 inside the absolute value, it evaluates to become +20 because the absolute value is the positive answer. So now I'm just going to solve both of these equations, subtract 4 and divide by 2 for both. And I got 2 different answers. One of them was 8, one of them was -12. Great. 83. Oh, cool. This is a quadratic equation. So of course I want to start by seeing if I can factor this. If it's not factorable, then I'll result in using the quadratic formula. So factoring this, I want my b value, so -7, then my ac, which is -18. So seeing that this I do have numbers that will multiply to 18 and add to 7. I'm going to be able to factor this. Those numbers are -9 and +2. So now I'm going to say 6x squared minus 9x plus 2x minus 3. And I'm just working on the left-hand side, so I'm ignoring the equals 0 until I need that step. Now I have 4 terms, so underline the first 2, draw up last 2 to visually help me separate where I'm taking out my GCF. 6 and 9 are both divisible by 3. Taking that 3x to the outside of parentheses and then doing the division, giving me 2x minus 3. Oh, cool. I see that the last part is 2x minus 3 already. So I'm just going to take out the +1 so that I'll be able to do the next step. Then I set these factors into their own parentheses. And it's back to being equal to 0. At this stage, I'm now going to set each individual factor equal to 0. 3x plus 1 equals 0, and 2x minus 3 equals 0. From here, we solve for x, which is 2 steps. -1, and then divide by 3. So we got -1/3, add 3, and then divide by 2. +3/2. So with exponent of 2, we get 2 answers, but also for absolute value, we get 2 answers because of the shape that those graphs make. All right, cool. We're doing great. We've got enough time for one more problem, and it'll be 84. 84, we see that we want to be able to write these with a common base. Seeing that 2 is smaller than 4, we're going to want to write 1/4 with the exponent with 2 as the base. So that's going to be 2. And I know it's 2 to the second power that makes 4. So to make it into a fraction, it was -2. Then I have n plus 1. That's going to equal to 2 to the 3n minus 5 power. Now I can distribute, and I have the 2's are no longer necessary. I have -2n minus 2 is equal to 3n minus 5. I'll add 2n. Oops. And I'll add 5. And I have 3 is equal to 5n. Dividing by 5, I get n is equal to 3/5. And that's going to be all we have time for today.